Hi everyone, my name is Christian Silva. I'm a PhD student at the University of Stirling in Scotland, and I am going to be talking about the use of Sentinel-1 satellite and temperature to monitor tropical agricultural fields. This is joint work with my PhD supervisors and co-authors, Armando Marino and Ian Cameron. In this research, we used asparagus crops located in the north of Peru. So you can see on the left a Sentinel-2 image acquired in September of 2018, just for comparison purposes. And then in the center, we can see an RGB composite of a Sentinel-1 acquired one day after the Sentinel-2 image. And then in the bottom here, we can see the local conditions for temperature and solar radiation. I'm just showing here this to highlight the fact that because the winters are mild, reaching minimum temperatures more or less of 16 degrees Celsius, the crops don't have a natural senescence that is forced by the local conditions, and this provides an advantage for farmers to be able to grow asparagus all year long and even have parcels at different stages at the same date. So part of this work focused on analyzing the impact of the temperature on the canopy development, but I will not cover that part here because of time constraints. I will mostly focus on the application of estimating the crop development or following the crop development. So in summary, we developed a method to approximate the crop stage after every new Sentinel-1 image. For this task, we use the backscatter measurements, the accumulated temperature during the season, and the day of the year when that season started. So we did not approach this as a classification problem, but rather as a regression problem, since we are not trying to estimate a crop stage for a parcel, but we are trying to estimate how many asparagus stems from the ones present in the parcel, how many are in emergence, how many in ramification, how many in aperture, how many in flowering, and how many in maturation. So we needed to provide 5 separate estimations, each one of them predicting the number of stems in each phenological stage. And therefore, we used a multiple output random forest regression for this task. So this figure here shows the prediction or estimation of asparagus stems that are present in each stage. As you can see, we have 5 maps, each of them corresponding to the prediction from each output of the multi-output random forest regressor. Additional to that, we developed a different way to display the same results, which is basically an RGB composite in which the blue channel, we use it to show the prediction of asparagus stems in emergence. In green, we show the asparagus stems in maturation, and then in red, we show the asparagus stems in ramification, aperture, and flowering. We combine these 3 stages because they are really short and consecutive. So as you can see on the right, the result is probably more intuitive and easy to understand. And then this slide here shows the temporal evolution of the fields. So I encourage you to stop this video and follow follow a group of parcel or a parcel and see how they evolve and go from one stage to the next stage in time. You can also see that there is not only green, red, and blue colors, but there is a combination between them, which basically means that there is for those cases, the parcel would be transitioning or would be in the middle of the transition from one stage to the next one. So that is it for the moment. Thank you very much for listening. Here's my email. You can contact me if there's any question or any comment about this work. There is also a reference where you can check more in-depth analysis of all of this. Thank you for listening.